Good day, everyone, especially to our committee. I'm Lance Kenneth Narvaez from the Philippines. I'm currently taking Master of Science in Computer Science at Technological Institute of the Philippines. This study aims to detect fake news more accurately by combining the contextual power of BERT and the efficiency of Navy Base. Let's begin with the background of the study and why this study is important. Fake news is a rising issue in the contemporary digital age because it spreads rapidly online and social media, typically ahead of verification. Also, fake news is a real threat on social cohesion through the manipulation of public opinion, disruption of political communication, and informing decision making at the individual institutional levels. In the Philippines, in the age of 18 to 24 is the most dominant group of social media users with 52.7% of population being social media users according to Talkwalker 2019. Filipinos are also among the internet users worldwide with a total number of 73.91 million individuals online and daily usage approximately 10 hours as of January 2021. Let's move on to the some gaps in detection models. Some problems still exist. First is the limited performance of single model approach. It's failed to fully capture the complex patterns. And second one is the consistency across datasets. It challenged the fake news detection, inconsistency in model performance. Next one is the high computational cost. It costs high computational requirements. And next one is the lightweight hybrid solutions, which is a well-balanced hybrid model that leverages both performance and efficiency, remain underdeveloped. Next one is the low latency and real-time performance. Uh, the news verification, low latency, and real-time response are essential. And the last is explored assemble techniques, which is generalized are rarely explored despite their promises in enhancing both accuracy and robustness. To address these gaps, I propose hybrid model. First is to develop a hybrid model combining both contextual embeddings and library-based for efficient classification. Second one is focusing on improving accuracy, precision recall, and computational efficiency. And the last is evaluating models' performance compared to standalone and traditional models. Now let's give me a brief overview of BERT and Navi-based algorithm. First is the BERT algorithm, which distinguishes context of word base of both preceding and succeeding words. Also, BERT is generates dynamic embeddings that change based on the context. Major advantage of BERT is flexibility through fine tuning. And the next algorithm is the Navi base, which is simplicity and speed, making it suitable for scenarios that demand low latency and minimal computational resources. Then the strength of Navi base lies into simplicity and adaptability and provides a clean and interpretable classification mechanism. So, how do they work together in the hybrid setup? In this part, the proposed BERT Navi-based hybrid model follows a structured two-phase architecture, which is training and prediction. To explain this architecture, here's the simplified concept how the system works. For example, our headline is the government approves the healthcare of citizen. In the phase one, the headline was processed in the level news, fake or real, and vectorized using TF-IDF, and it builds a numerical representation of word importance. Then after the training with multinomial library base, it learns the probability of words occurring in the headline, it's fake or real. Simultaneously, the headline tokenized and fine-tune the BERT because it learns contextual patterns from real versus fake content. In phase 2, the prediction phase, for sample headline, the headline government approves healthcare all citizen is tokenized for BERT and creates embedding like CLS. Then TF-IDF vectorized generates a sparse vector of words importance. Then in the model prediction, the class probability of multinomial live-based outputs are fake is 0.30 while real is 0.70 based on word frequencies across training sets. The class probability of BERT outputs are fake is 0.20 while real is 0.80. It based on deeper sentence context and learned patterns. In this weighted score fusion, let's say our tune weights are alpha BERT is 0.6, while multinomial alpha is 0.4. The final score calculation is the fake is 0.24 and the real is 0.76. The prediction is real with the confidence score of 0.76. This example shows how the system weighted average and make with a balanced interpretability and depth. Now let's look the objectives of my study is to develop and evaluate a hybrid bird naive-based model for fake news detection, optimizing performance through future extraction methods and comparison with existing models. And the specific objective of my study first is to develop a hybrid naive-based model that achieve high accuracy, precision, and recall is distinguishing real from fake news. To attain that, I trained a naive-based BERT model in Google Cloud, and this is the result training performance and validation performance of the model. Now let's look how the hybrid perform numerically. This table present perform a hybrid naive-based BERT model across 5 epochs on the training and validation dataset. In the training metrics, the precision increase and suggesting that the model becomes better to avoiding false positive over time. The recall is steadily from high capability of correct identifying fake news. F1 score rises from and confirming the model maintains a good balance in between these two aspects. Accuracy improves, demonstrating strong learning progression and model convergence without overfitting. In the validation performance, precision, consistently accurate fake news predictions, while recall remains robust and suggesting reliable detection of actual fake news items. F1 score and accuracy showing a strong generalization ability to unseen data and minimal performance variance. And in these objectives yielded the following results. The hybrid BERT based model was determined to have a 93.8 accuracy in validation and being 0.98 all along, high classification performance all the measures, and strong identification even noisy and uncertain data, and stability of performance across numerous spokes with less overfitting. And the next specific objective is to evaluate and fine-tune the performance of developed hybrid BERT naive based model by assessing its accuracy, precision recall, and F1 score on validation dataset and comparing it to the existing fake news model. To attain that, I trained standalone BERT model with existing fake news model in Google Colab and compared it to naive based model. Also, I'm trying to train hybrid model using random forest and SBM BERT. Now, let's compare with other approaches. This table presents the evaluation of 4 fake news detection model based on core performance, and this metrics is comprehensive view of how well model classifies real news. To understand the metrics, precision measures how many articles labeled as fake were actually fake. Recall assess how many of actual fake articles were correctly identified. F1 score is harmonic mean of precision and recall. And lastly, accuracy reflects the overall rate of correct classification, both fake and real. The standalone BERT models show moderate performance, lack the high precision and recall, while naive-based BERT has excellent performance, near perfect scores. BERT tips contextual embeddings and naive-based efficient probabilistic classification, highly accurate and balanced and robust. Then semantic understanding and fast interpretable decision making, best performing model overall. Random forest BERT matches the performance of naive base, and it's more complex and resource intensive and higher computational cost and less interpretability, but naive base is preferred. While SBM BERT is slightly drop in precision and recall indicates misclassify more cases and struggle with the long scale high dimensional data. And in this objective yielded the following results. Accuracy was increased by 11.3% and training time also increased, reflecting in additional embedding and classification step. And lastly, prediction time was slightly longer but was still faster than hybrids with deployability speed in the site. And the last specific objective is to evaluate the efficiency of hybrid naive-based model in terms of time and resource it consumes during both training and prediction phases. To attain that, I evaluate 4 models in terms of resources its training and prediction phases. Now let's assess the computational efficiency. In the training time, standalone BERT is fast training time, while the hybrid models hybrid base has longest training time but difference marginal, while random forest and SBM are slightly faster in training. In prediction analysis, standalone BERT is fastest in prediction time, while Naive-based BERT performs exceptionally well, only zero point 0.2 in prediction time, still near real time, while random forest and SBM has noticeably longer inference times, less suitable for high speed or real time detection system. Now let's proceed to the resource consumption during training. In the training phase, before training starts, all model report 0% GPU utilization, meaning GPU resource were not yet engaged. Then CPU usage is high in random forest and IV base, while standalone BERT has low CPU usage in pre-training. While after training, the Navy base and random forest and SBM all utilize 96% of GPU resource post-training, while standalone BERT barely used GPU 2%, which explains faster training time. And in memory, hybrid consume high GPU memory, while standalone BERT much less. In the CPU usage, increased for all models post-training, while standalone BERT spiking the most. And the next is in the testing phase. Now I'm going to show the resource consumption during testing phase. Before testing, the Navy base and random forests are lightweight before testing, showing memory usage and moderate CPU load, while standalone BERT surprisingly shows very high memory usage, while SBM shows the highest pretest memory usage. Then after testing, standalone BERT show extreme high CPU usage and no GPU utilization, while Navy base and random forest both maintain balanced CPU usage, indicate efficient and scalable inference, while SBM have spike in both CPU and memory use. And in this objective yielded the following results. Mm, Standalone BERT training time is slightly more than but better than other hybrid approach like random forest and SVM. Naive-based prediction time of zero point 0.2 seconds faster than other hybrid models. Computation resource consumption were maintained within reasonable and during training inference. And last is high trade-off between efficiency accuracy, particularly against the computational expensive model. Let's now talk about the scope and limitation of the study. The study focused on evaluation of hybrid BERT and IBS model for fake detection. This study uses isolated fake news dataset, and this research centered on the detection fake news from the sources such as media articles on the websites. And the significant areas are the political news, health and science misinformation, economy and finance as critical and diverse capture of fake news. The performance of the models will be calculated using measures such as accuracy, precision recall, and F1 score, and confusion metrics for more informed understanding of the result. Why is this study significant despite the limitations? Many stakeholders could benefit from it. First, general public. An individual will be able to use data with better capability to go away from fake news. Second is policymakers and regulators. This study will be useful in developing policies and plans that will reduce the spread of fake news. Next is the media organization. This protects the rightness of journalism, improve loss of trust of the public. And next is the educational institution, make people ready for responsible, efficient exploration through the digital platform. The next one is the future researcher that can build the addition of more features, dataset or hybrid methods. And the last is the social media platforms can be help Facebook, Twitter, and YouTube identify and reduce the dissemination of fake news through their channels. Based on this, there are some recommendations from the result of conclusion of the study. The following recommendations are proposed. First is the further testing in the real world allowed practical verification. Second, the training in the model should optimize discovering various other applicable embedding techniques, software acceleration methods. Third is combine various machine learning classifiers with BERT, maybe even decision trees or deep neural networks to see if any further enhancement can be made. Fourth is evaluate model in larger and more diverse datasets like multilingual news articles in order to generalize robustness across different linguistic and cultural contexts. The last is use explainable artificial intelligence or SI techniques to make hybrid models interpretable. That's all. Thank you for listening.